Now, number 8. It's the same exercise as number 7, but with different values. So first of all, so this is 0.3. Between C1 and C2, 0.5. Between C2 and C3, 0.9. C3 and C4, 1.3. 1.7, and finally 2. So C0, C1 equals 0.3 centimeters. C1, C2, 0.5 centimeters. C2, C3, 0.9 centimeters. C3, C4, 1.3 centimeters. C4, C5, 1.7 centimeters, and C5, C6, 2 centimeters. The first question, compare the distances traveled by the puck in equal time intervals. Conclude. So, part A, you have to say different distances. Different distances are covered with the same time intervals. As you can see in this exercise, between each two instants I have tau, the same period of time. I have different distances, whereas in the other number, in number 7, I had equal distances in equal times. B. Calculate the average speed of the puck between any two instants you choose. Conclude. Okay. Let's say if I want the average speed between C0 and C2, average speed equal C0, C2 over 2 tau equal C0, C2, yani both of these segments, 0.8. This is in centimeter, it has to be in meters, so times 10 minus 2 over 2 tau, yani 2 times 0.1 equal 0.8 divided by 100 divided by 0.2, 0.04 meters per second. Let's say I want the average speed now between C1 and C5. It's equal C1, C5 over how many intervals of time do I have? 1, 2, 3, 4. So 4 taus equal C1, C5 is 0.5 plus 0.9 plus 1.3 plus 1.7 all over 4 times, أكيد times 10 minus 2 هون times 0.1 equal 0.5 plus 0.9 plus 1.3 plus 1.7 over 100 over 0.4. The answer is 0.11 meters per second. As you can see, I have different speeds. So the average speeds aren't the same. We were expecting that since the puck didn't cover the same amount of distance during the same amount of time. Now, part C. Calculate the instantaneous speed of the puck at 3 instants you choose. Let's say V1 at C1. So I have to do C0, C2 over 2 tau. V2 at C2 at t equals to 1, if you want to say t equals to 1 seconds, t equals to 2 seconds. Okay, this is C1, C3 over 2 tau. V3 at t equals to 3, so C2, C4 over 2 tau. V4 at t equals to 4, C3, c5 over 2 tau, and finally v5 at t equals to 5, c4, c6 over 2 tau. Now let's replace. So v1 equal c0, c2, 0.3 plus 0.5 over 0.2 times 10 minus 2 always. هلا we will calculate them. v2 equal c1, c3, so 0.5 plus 0.9 times 10 minus 2 over 0.2. v3 equal, v3 is c2, c4, which is 0.9 plus 1.3 over 0.2, all of it times 10 minus 2. v4, so 1.3 plus 1.7 over 0.2, and finally 1.7 plus 2 over 0.2, all of it times 10 minus 2. Now 0.8 times divided by 100 divided by 0.2. The first one is 0.04 meters per second. This is v1. The second 0.5, 0.9 over 100 over 0.2. It's 0.07 meters per second. This is v2. 0.9 plus 1.3 over 100 over 0.2 equal 0.11 meters per second. As you can see, this is v3. It's changing. 1.3 plus 1.7 over 100 over 0.2, 0.15 meters per second. This is v4. 1.7 plus 2 over 100 over 0.2, 0.185 meters per second. This is v5. So v1 different than v2, different than v3, different than v4, different than v5. I don't have a constant speed. Now D. Calculate the average acceleration of the puck between any two instants you choose. Conclude. Okay, let's say the first one. A. v2 minus v1 over 2 tau equals, I'll call this A1. A2 v3 minus v2 over 2 tau. A3 v4 minus v3 over 2 tau. A4 v5 minus v4 over 2 tau. Let's replace. v2, it's 0.07 minus 0.04 over 0.2. v3, 0.11 minus 0.07 over 0.2. v4, 0.15 minus 0.11 over 0.2. v5, 0.185 minus 0.15 over 0.2. Let's find the answers now. 0.07 minus 0.04 over 0.2. The answer is 0.15 meters per second square. 0.11 minus 0.07 over 0.2 equals 0.2 meters per second square. 0.11 minus 0.11 over 0.2 equal also 0.2 meters per second square. 0.185 minus 0.15 over 0.2 equal 0.175 meters per second square. As you can see, all the answers, all the accelerations are so close. Of course, when we are working with pucks and with so small distances and so small times, we might have a difference in the answers. This is why we can say A1 approximately equal A2 approximately equal A3 approximately equals A4. So in this case, the acceleration is constant. So I have uniform accelerated rectilinear motion.